Let's calculate the cache size given these conditions. Find the total bits of required for cache if a drag map cache with a 1 kilo word block size of 4 bytes and 32-bit addresses using byte addressing. How we find the total size? We said total size of cache equals 2 to the n times block size plus hex size plus valid bit, and all of this should be in bits. This text size in bits and the block size in bits, and this is in bits, so we don't have to worry too much about it. So from here we need to find text size, and the block size is given right here, and then valid bit is going to be always equals to 1, and sometimes there is also called dirty bit as a D. This is V equals to 1 bit, and also dirty bit D equals 1 bit. For this exercise, we're not going to worry about this 30 bits. So we'll use this formula as we discussed in class. Step number 1, how you find the n. We know 2 to the n equals cache size over block size. What is the cache size? Total cache size is 1 kilo word over block size 4 byte. Why is this? Because this 2 to the n will give us total number of index or set is required for that cache. Numerator is a word, so 1 kilo word is 4 byte in our definition, and the 4 byte cancel out. We have 1k, which is 2 to the power of 10, therefore n equals to 10. That means 10 bits long for index or set. Step number 2, how about text size? Text size equals the total number of bits for address. In this problem, we have a 32-bit long address. Therefore, 32 minus, within that memory address, we need to subtract n, which is index, and m, and 2. We know this n. What about this m? 2 to the m word equals the block size in word. How many bits we need to designate for the number of words in a block. And this problem, we said we have block size in 4 byte, which is 1 word. So 2 to the m word equals 1 word. Therefore, m equals to 0. Now, what about these two? This is the byte address. So that in a given word, we have 4 bytes. Therefore, we need to designate 2 bits for the byte addressing. If we say word addressing, then this guy is gonna be 0. Now the text size then, 32 minus n equals to 10, m equals to 0 and 2. So 32 minus 12, which is 20. Now the total size of cache now equals 2 to the n, that is 10, by block size 4 byte, text size 20 bit, valid bit 1. Then we have 2 to the 10 times 32 plus 21, that is 2 to the 10 by 53 kilobits. That makes sense if you look at this diagram. So total data bit is the 32-bit. This is the block size because we need to read as a block, and it is a byte addressing. Therefore, we have to have 2 bits to distinguish which byte we are talking about. And then the tag is 20 bits, and then valid bits. So this is 1 plus tag is 20 plus each block is 32-bit. So 32 plus 20 plus 1, that is 53. And index or the set is total 1024, which is 2 to the 10. So that is the size. When we calculate the size of the box, we need to multiply width times length. So that is exactly how we calculate here.